In this video, we're going to learn how to use tables to help with probability questions. So there's a table here that shows upperclassmen, underclassmen, so juniors and seniors, freshmen and sophomores, total number of students, and GPAs. GPA greater than or equal to 3, less than 3, or between 2 and 3, and then less than 2. So the first question, and I know it's small, 3A, what is the probability that a randomly chosen student has a GPA that is greater than 3? So a randomly chosen student has a GPA greater than 3. So find that on the table. It's 262 out of the total 1200. And I'm not going to simplify these fractions right now. I'm just going to put them what they are on the table. B, what's the probability that a randomly chosen student is an upperclassman? So an upperclassman, let's get rid of these yellow dots. All right, upperclassmen. So there are 568 upperclassmen out of 1,200 students. 568 upperclassmen out of 1,200 students. Next, what is the probability that a randomly chosen student is an upperclassman and has a GPA less than 2? So upperclassman is the top row of numbers, a GPA less than 2. So now we're only looking at 81. So when there's two criteria, you need to you can look at it as a cross section of the two things. So 81 out of 1,200. D, what's the probability of a randomly chosen student is an upperclassman and a GPA less than 2? Oh, it says or a GPA. So let's be real clear right here. This is different because it says the word or. So there's two criteria here, but it's not an and problem. So letter C said and. So it was the intersection of those two criteria. Okay, we kind of drew the line going across, the line up and down. This one says the probability that it is an upperclassman or less than 2. So if we take the total number of upperclassmen, this is kind of like the cards problem, where you define the hearts or a face card. So to add up all the hearts and then add up the other face cards. So I have 568 upperclassmen, and then the other numbers that are less than 2 is 103. I'm not using the total, 184, because that would cause me to count 81 twice. There's 568. That's from all the upperclassmen. And then who else has a GPA less than 2? Well, the other group that has a GPA less than 2 besides the upperclassmen I already counted is this 103. So I need 568 plus 103. Over 1,200. So 568 plus 103, that'd be 668 plus 3 is 671. And then the last question, what's the probability that a randomly chosen student does not have a GPA less than 2? So you could do that a couple ways. GPA not less than 2, you could add up these two numbers, 262 and 754, and just do that over 1,200. Or we could use that idea of a complement that we talked about in a previous video. A complement, we could find the probability that person is less than 2. So 184 out of 1,200. The complement is 1 minus that. Basically, what's 1200 minus 184? Same thing as 262 plus 754 over 1200. And I'm not going to add those two up right now. All right, with tables. Tables are a good way to look at conditional probability. Conditional probability means that you're finding the probability of an event, but you already know that another condition has occurred. So you already know something. I always say that these are problems where you know more information, so it changes the probability. There's 3 problems on this page. The bottom one is a conditional probability. So let's see what 2 like just normal table problems look like. 7a. What's the probability the person in the population is 17 or older and likes hockey? So reminder, when we're doing an and problem, you're going to look at the intersection of the 2 rows and columns. So 17 or older and likes hockey. So there are 15 people that meet that criteria, 17 or older and like hockey. So that'd be 15 out of 300. The second one says, what's the probability the person in the population is 17 or older or likes hockey? So 17 or older or likes hockey. When we have the or with the 2 criteria, we take one total, 17 or older, which comes from the 60 plus the 15, and we have to add up the other criteria, or they also like hockey. So there's 125 other people who also like hockey. So 125 plus 75 over the 300. So 200 over 300, which we could write that as 2/3, because we usually almost always write that as a reduced fraction. C says, what is the probability that a person is 15 to 16 years old, given that they do not like hockey? And I'm going to see if I can put this one in bold, since it's our conditional probability question. So our condition is given that they do not like hockey. So that means instead of looking at this 300, we don't have 300 to look at anymore. So I'm actually just going to cross that out. We don't have 300 to look at. So given that they do not like hockey, so we got rid of the 300 because that's not the total we're looking at. We are looking at the fact that they don't like hockey. So out of this new total, what's the probability that they are 15 or 16? So my answer is going to be 100 out of 160. And again, we simplify that as much as we can. It's 10 out of 16, so 5 out of 8. So what's the probability a person is 15 or 16 years old, given that they do not like hockey? That when you have that given that, that's a condition. That means that you're going to find a new total in that condition and answer the question based on that new total. So here's 2 examples of conditional. The first one says, what's the probability that a randomly chosen student has a GPA that is greater than 3, given that they are an upperclassman? So you were told they are an upperclassman. So we're looking at 568. We are not looking at this total. So given that they are an upperclassman, what is the probability that the chosen student has a GPA greater than 3? So 125 out of 568. The second one says, what's the probability that a randomly chosen student is an upperclassman given that they have a GPA greater than 3? So this time your conditional statement changes. You're given they have a GPA greater than 3. So you're looking at 262 students. What's the probability that they are an upperclassman? So that's 125 out of 262. So 125 is the same in both problems. But the first time you're given that as an upperclassman, so then you're choosing the number of students that have a GPA greater than 3, 125 out of the 568. The second time, you're given they have a GPA greater than 3, so there's 262 total students, and then you want the upperclassmen, so 125 out of that. If I had a deck of cards, what's the probability that a card is a spade given that it's a black suit? So normal probability here, we would say it's something out of 52 because there's 52 total cards. But given that it's a black suit, there are 26 cards that are black. So that changes to 26. What's the probability that it's a spade? There's 13 spades out of 26. So if you know it's a black card, it's 50% probability that it's a spade. What's the probability a teacher is a female at Parkwood Central High School, given that they're in the math department? So instead of taking the entire staff or a staff of teachers at Parkway Central, we're just looking at the math department. So that's nice because there's only 12. So now there's 12 teachers to choose from. How many are female? Miss Elder is 1, Miss Crusoe is 2, Miss Merriman is 3, Mrs. Horman is 4, Miss Beal or Miss Jafari is 5, Miss Reeves is 6. So it looks like that would be 6 out of 12 or 1/2. Papulus is male, Altman is male, it's 2, Lehman's male is 3, Wilson's male, it's 4, Schaefer's male, it's 5. So who did I miss? I may have missed Bird. Let's go with 7. So Elder, Crusoe, Merriman, Horman, Bird, Beal/Jafari, and Reeves. So 7 out of 12. 7 out of 12 is not 1/2. And that's it for conditional probability and using